define the idea of orthogonality.
Okay.
So two signals are orthogonal. The integral of 0 to t, e to the j 2 pi kt over big T. I'm going to check to make sure I'm writing this right. E to the j 2 pi lt big T dt. Let me just check.
It has been quite a few years since I've taken ordinary differential equations, so I can't quite help you out here just to make sure that this is right. But yes, I do remember that you can define orthogonality for two functions.
Yeah.
By computing the integral of their.
Just put a minus sign here. Yeah.
Of the product of the two.
So the minus sign just makes this math a little easier.
Okay.
Equals. So it equals 0 if k does not equal L.
Okay.
And it equals. It equals t if k
is equal to
equals
L.
L.
So what is the significance of this? I understand the orthogonal definition. This mirrors what we know from linear algebra.
Mm-hmm.
If you have two vectors, and you take the dot product of them, and if that's equal to 0, by definition, those two vectors are orthogonal.
Right.
Well,
I'd like to say one thing. So the dot product is just a special case of the inner product.
Yes.
And the inner product, the dot product is for vectors, but the inner product generalizes to functions, for example.
Yes.
So this is a case of the inner product of two functions. When we use vectors, we do the dot product. So this is just a way to generalize that. And now what this is doing is basically we know that, for example, sine of t and sine of 2t are orthogonal.
Okay.
And you can look at this by they're integer multiples of each other's frequencies.
Okay.
Yeah.
Okay.
And so if we were to multiply them and take the integral, we would get 0.
Okay. That's something worthwhile for me and everybody else to try to work out.
Mm-hmm.
Okay.